We're going to talk about parallel lines and triangles and how that impacts similarity. Parallel lines and triangles and how that impacts similarity. Once again, please record the location and the time that you are watching these videos. Please record the location and the time that you are watching these videos. Taking a look on page 19. Page 19, we're going to graph this line. So first what we want to do is we want to change it to y equals mx plus b. So we're going to add 6 to both sides. Or we could change it to the standard form, which I'm going to do. So we're going to add 6, add 6. So let's swap this around so you recognize it. It's going to be negative 3y plus 6x equals positive 6. Let's switch this around one more time so you recognize it in standard form. We have 6x minus 3y equals 6. I'm going to use the intercepts, where y is 0, that's your x-intercept, and where x is 0, that's your y-intercept. So if we put a 0 in the y and we say goodbye to it, we get 6x equals 6. X is going to equal 1. And if we come over here and put a 0 in the y, cross that out, we have negative 3y equals 6. In this case, y is going to equal negative 2. Now we plot both points. 1, 0, that's your x-intercept, and 0, negative 2, that's your y-intercept. You string a line through that. And that is the equation of the line for 6x minus 3y equals 6. Taking a look at today's concept, we're going to start with a very, very simple concept. You have a triangle. You're going to need a straight edge, colors, a pencil, and a highlighter. Now what I'd like you to do is I first would like you to trace and stretch out this segment P to R. Trace and stretch out the segment P to R using a ruler. So trace and stretch out P to R. Now we're going to draw a line parallel to PR but cutting through the triangle. Parallel to PR but cutting through the triangle. When this happens, you need to be able to view this in two different ways. We have a line intersecting in two different ways. You need to see it in two perspectives. The first perspective is you need to see the fact that there's now two overlapping triangles. Two overlapping triangles. We have a larger triangle. We'll call this P, triangle P. PQR. That's one way you need to see it, is the fact that you have a larger triangle and a smaller triangle at the top. And these triangles, because these lines are parallel, these triangles are similar. So that's the first way you need to see, is the fact that when a parallel line cuts through a triangle, then the triangles that are created are similar. A second way you need to see it as one individual triangle, but the segments on the non-parallel side, these segments on the non-parallel side, those segments are proportional. Again, proportional means you can make ratios. Those segments, let's draw them out, you can make ratios of them. So when you have parallel lines cutting through triangles, you need to be able to view them in both these methods. So once again, we have this scenario where when triangles are cut, you can have a larger, similar to a smaller triangle, or you see the segments of the one triangle on the non-parallel sides as proportional. Now, the trick is, when do you use which scenario? The one on the left, you can always use this all the time in every scenario. It's a one-size-fits-all method. The one on the right, be very careful, it only works in specific cases. It only works when the information is strictly on the segments only. That's the non-parallel segments. Let's take a look at here on the left. What should be the first thing you should do if you're going to use this method? Well, step number one is to separate the triangles. Separate the triangles. So you see here that you have a larger triangle and a smaller triangle. So the first thing we're going to do is separate or pull those triangles apart. We have a larger triangle and then a smaller triangle. And because our given lines were parallel originally, you saw these that they were parallel, the little arrow feathers mean that, then we can say that they are similar. It's very important you label this as carefully as possible. This right here is 6. This whole side is not 12. It's 6 plus 12. So this whole side is 18. This whole side is 4x minus 3. And we want our unknown segment. We're going to solve for x here. But in order to solve for x, we first must find a missing segment. We have here a little piece that we need. If you look carefully, this is a 1:2 ratio, 6 to 12. This also has to be a 1:2 ratio, which means our missing piece right here has to be 7. That makes this whole side 21. So we have 4x minus 3 equals 21. Now we can solve for x. Plus 3, we have 4x equals 24, x equals 6. Let's see if that actually worked. 4 times 6 is 24, minus 3 is 21. Yes, it does fit. On the right-hand side, if your information is limited to the segments only, the segments meaning the pieces of the two sides which are not parallel, you can go segment over segment equals segment over segment and cross multiply. Let me show you that there's actually several ways we can do this. We can go 10 over 16 equals 30 over 9x plus 3. Or we could go this way. 10 over 30 equals 16 over 9x plus 3. Or we can go the third way. We can go 30 over 10 equals 9x plus 3 over 16. Any combination works. The name of the game is mirror it. If you go left to right the first time, you have to go left to right the second. Top to bottom, top to bottom. Bottom top, bottom top. Either way, if you mirror it, then you simply cross multiply. Do not do this distributive in your head. We have 10 times 9x plus 3 equals 30 times 16. Now distribute. We have 90x equals 450. If you take off the zeros, it's easy to see that x equals 5. Another thing with parallel lines and triangles is this. I'd like you to eyeball the midpoint of P to Q and find the midpoint and hatch mark. We're going to call that J. Now on QR, also eyeball what looks like the midpoint. Call that K. Now I'd like you to connect J to K, please, using a ruler. Now what I'd like you to do is I'd like you to finger bracket. I'd like you to bracket with your fingers J to K, and then bring that distance down to P to R. You're going to notice something. Bring that distance down to P to R. Bracket J to K and bring that distance down. What you should notice is that the distance P to R is exactly double of J to K. This, J to K, that's called a midsegment. And a midsegment has two properties. It is half of the third side it's facing, half of the third side it's facing. It's also parallel to. So it's half of and parallel to. Half of and parallel to the third side. It's parallel to the third side and half of the third side. So in this one, we are given to find the length of B to C. So that is our unknown there. But we're told that BC is parallel to DE, and the fact that DE is a mid-segment. By definition, that means it is half of BC. So if we want to find the length of BC, we know B to C equals 2 of the mid-segments, which is DE. So now we're going to find the distance of D to E. D is at 1, 1. E is at 4, 3. Go ahead and write your template. I'm going to pause, let you write your template out. We're going to go subtract the x's, left to right. Subtract the y's, left to right. This is going to be negative 3 squared. It's going to be 9. This is going to be negative 2 squared. That's 4. Square root of 13, which is approximately 3.6. So here we have 2 times 3.6 equals our BC. So we have 7.2. So BC equals 7.2. Third thing you need to realize is that when you have parallel lines, they do create proportional segments. They create proportional segments. That means you can solve by using proportions. What are proportions? They're an equation of fractions. Let's take a look at what we have here at the top. The most important thing for you to do here is to mirror the image. Mirror the image. We have an unknown. Let's call that unknown x. Trace with me, please. In this case, we can go 12 over 16 equals x over 36. Notice I went from here to the bottom top, bottom top. Notice the direction I went for both this. This would also work. Again, trace with me, please. 12 over x equals 16 over 36. Went bottom top that way. That also works. We could also go this way. 36 over x equals 16 over 12. All three of these would work. Whatever proportion you start with, you must match it in a mirrored image. So we take any one of these and we cross multiply. We get 16x equals 12 times 36. Notice I didn't multiply things out because it's actually easier to factor. I'm going to factor 12. I get 3 times 4. Factor 36, which is 6 times 6. And down here it's 4 times 4. That's 1. Here I have 2 times 2. This is 2 times 3. This is also 2 times 3. Can cancel the 2's. End up with 3 times 3 times 3. So x equals 27. Now, it's really easy to check this. So let's check and see if this actually works. 12 over 16 equals 27 over 36. 4 goes in here 3 times. 4 goes in here 4 times. 9 goes in here 3 times. 9 goes in here 4 times. They both reduce to 3 to 4. So that's a correct ratio. Now be very careful with this. We have here 36. 36 is the whole proportion, so our mirrored image has to be the whole thing as well. We're going to call this x. So we can go 36 over this whole side over here, which is going to be 36 plus x, equals 20 over x. We went left to right. Another way I could have done this would be 20, which is the small over 36, equals our unknown, which is x, over the whole thing, which is x plus 36. Both would be appropriate. Now you just cross multiply and solve. We're going to have 20 times x plus 36 equals 36x. We have 20x plus 720 equals 36x minus 20x both sides. I have 720 equals 16x. Get x equals 45.